Welcome back, guys. We're going to do the last section of 8.10, talking about the definition of a Taylor series to find other series. The other day we were doing e to the x, sine of x, cosine of x series, and how to manipulate them to find other series. But keep in mind that those series were found by using this original definition. All right, so the value of the function at the center, first derivative at the center, x minus the center to the 1, second derivative over 2 factorial, x minus center to the 2, all the way up to the nth derivative at the center over n factorial, x minus the center to the n. Right. So sometimes we have no choice and we have to use this definition. It's the long way to do some series, but for some of them, we don't have an option. So I'm going to show you a multiple choice question and a short answer question that require that you use this definition. And the most common mistake that gets made that I've seen is students tend to forget the n factorial on the bottom. All right, it's not just the nth derivative times x to the n or x minus a to the n. You have to have this n factorial on the bottom. And sometimes we can do problems where they might give you a series and ask you to find certain pieces, like the second derivative at the center. But if you know this term, you could set this equal to the value they give you, and you could solve for this value as well. Okay, so for a multiple choice question, that requires that you know this rule. Okay, so it says the nth derivative of a function f at x equals 0, so that will be our center, is given by fn of 0 equals negative 1 to the n times n plus 1 over n plus 2 times 2 to the n. And we're going to use this function for all n greater than or equal to 0. So if n is 0, that would be the 0th derivative, which would actually be the value of the function at 0. So they're not giving you the function, they're just giving you a way of finding its nth derivative. But that's all you need in order to find a series. So this is not the function. This is basically how we find the nth derivative. So they want you to find the Maclaurin series for f. So they say Maclaurin series because, again, it is centered at 0, but sometimes they could also say it's a Taylor series centered at 0. So if we're using the definition, we need to find the value of the function at 0, first derivative at 0, second derivative at 0, third derivative at 0, and that's pretty much as high as we need to go. But keep in mind, this is a multiple choice question, so we might not even have to go that high. So to find the value of the function at 0, that would be the 0th derivative. And we're allowed to use this function when n is 0 because they did define that here. So if we replace all of our n's with 0, we get positive 0 plus 1 is 1, 0 plus 2 is 2, 2 to the 0 is 1, so we get positive 1/2. Now if we want to find the first derivative at 0, we're going to replace n with 1. So that'll give us negative 1, 2 over 3 times 2 to the 1, which would reduce down to negative 1/3. And then if we wanted to find the second derivative at 0, we're going to replace n with 2, so we get positive 3 over 2 plus 2 is 4, 2 to the 2 is 4, so 4 times 4 is 16. So we get positive 3 over 16. So I'm actually going to stop here because I think that's as far as we can go, because if you look at the options, none of the answers all have the same first 3 terms. So now if we use our definition, so we're going to start with the value of our function, which is 1/2, which means we can eliminate a as an option. And then we're going to take our first derivative over 1 factorial times x to the 1, right? Because the center is at 0, plus our second derivative over 2 factorial x squared. So if we look at these 3 terms, we know the first term has to be 1/2. The second term would reduce down to minus 1/3 x. So now we're down to just b and d. And now this term, the 3 over 16, we have to divide by 2 factorial, which would give us 3 over 32 x squared. So that means our answer is going to be D, not B. All right. B would be the answer if you forgot to divide by the 2 factorial, which again is a common mistake made. But if you're using the definition of a Taylor series, you need to make sure you do that. Okay, so if you want to move on to the next video, we can do the next example. And then the last side has your AP question, which will be your assignment that will be due on Friday.